Hello everyone, how are you all? This is Mr. Ahmed Samir and we are still in Unit 2 with solving first degree inequality in one unknown. Firstly, let's review the equations to remember it by using examples. Firstly, find the solution set of the following equations where x belongs to z. X plus 6 equals -5. We have two sides and between them equal relation. The left hand side x plus 6 and the right hand side is -5, and between them equal, the symbol of equations. Firstly, we will move or translate 6 to the opposite side, the inverse side, by inverse operation will be -6, and the remaining is x alone in the left hand side, and -5 minus 6, -5 -6 equals -11. So the solution set is -11. Another example, 3x equals -9. We will move 3 to the other side by the inverse operation. The inverse for multiplication is division. So the remaining in the left hand side is x, and the right hand side will be -9 divided 3 equals -3. So the solution set is -3. Let's learn how to solve the inequality. But before this, let's remember what is the meaning of inequality. We learned it at the first lesson. What is the meaning of inequality? This is a mathematical sentence contains an inequality relation. Inequality relation like less than or equal, greater than or equal. Let's see how to solve the inequality by an example. Find the solution set of the following inequalities. X minus 1 greater than 3. By the same way of solving equations, we will solve this inequality. We have now two sides. Left hand side is x minus 1 and right hand side is 3. The relation between them greater than, but in the equation the relation between them was equal. Let's see. I want x only in the left hand side, so we will move a -1 to the other side by the inverse operation will be +1. So the remaining here x in the left hand side, and 3 plus 1 equals 4. What are the integers greater than 4? Let's see. The integer greater than 4 will be 5, 6, 7, 8 to infinite. Then the solution set will be 5, 6, 7, 8, 9 to infinite. Let's represent it by using the number line. This is the number line, contains the positive integers and the negative integers and 0. So this inequality will be represented as from 5, 6, 7, and we will draw array represents the infinite like this. By another example, find the solution set of the following inequalities where x belongs to z. X plus 5 greater than or equal -2. Let's move +5 to the other side by inverse operation will be -5, and we will remove it from the left hand side. So the remaining in the left hand side is x greater than or equal -5, -2 equal -7. So the integers that greater than or equal -7 will be -7, -6, -5, -4 to infinite. Now we took -7 because there is equal, greater than or equal, not greater than only. Okay, let's see. Solution set is -7, -6, -5 to infinite. Let's represent it by the number line. -7, -6, -5, -4, -3, -2, -1 to infinite, and we will draw ray represents the infinite. By another example, 2x less than or equal -4. Let's remove 2 and move it to the other side by the inverse operation, -2. The remaining is x less than or equal -2. The integers less than or equal -2 are -2, -3, -4, -5 to infinite. By using the number line, we will put closed circles on -2, -3, -4, -5, -6, -7 to infinite. Find the solution set of the following inequalities where x belongs to z. 5x minus 14 greater than or equal -4. Firstly, we will move -14 to the other side by +14, and we will remove it like this. The remaining 5x greater than or equal -4 plus 14. We have different signs, so we will subtract and we will take the sign of the greatest integer. So -4 plus 14 equals 10. 5x greater than or equal 10. We will remove 5 and we will translate it to the other side by divide 5, because the origin operation is times. 5x is 5 times x. We will move it to the other side by divide 5 like this. So the remaining in the left hand side is x greater than or equal 2. The integers greater than or equal 2 are 2, 3, 4, 5, 6 to infinite. By using the number line, we will put closed circles on 2, 3, 4, 5, 6 to infinite by using array. Another example, 1 minus 8x less than 33. 1 negative 8x less than 33. Firstly, we will remove 1 from the left hand side and we will translate it to the other side by the inverse operation like this. The remaining in the left hand side is negative 8x less than 33 minus 1 equal 32. So in the left hand side is negative 8x. Negative 8x means negative 8 times x. Now we want to remove negative 8 from the left hand side and translate it to the other side by inverse operation. But we have a remark here. If we divide it by a negative integer like negative 8, the sign of inequality will flip to the other side. How this? Let's see. Now we have less than, but we divided by negative integer is negative 8. So less than will flip to greater than like this. Again, if we divide it by a negative integer, the sign will flip to the other side like this. Less than, but we divided by negative 8. So less than will become greater than. The integers greater than negative 4 will be negative 3, negative 2, negative 1, 0 to infinite. And by using the number line, we will represent it like this. By another example, find the solution set of the following inequalities but x belongs to n. X must be natural number, 0 or positive integers. Let's see. Negative 2x plus 19 greater than or equal 11. Firstly, we will remove positive 19 to the other side by negative 19. The remaining negative 2x greater than or equal negative 8. We will divide in the right hand side by negative 2, but negative 2 is negative integer. If we divide it by negative integer, the sign will flip to the other side, like the last example. So the remaining x less than or equal 4. So the solution set 4, 3, 2, 1, 0 only because x belongs to n. So we can represent it by 0, 1, 2, 3, 4 only. Another example. Third x less than negative 1. Third x means third times x less than negative 1. So we will remove third and we will translate it to the other side by divide third. The remaining is x less than negative 3. The integers less than negative 3 are negative 4, negative 5, negative 6. But these integers not belong to n. So the solution set will be phi. Thank you for listening.